In this session, I'm going to make an introduction to the next generation IPS functionality available on Firewall threat defense. FTD offers excellent NGIPS features that are mostly based on the Snort engine, open source intrusion prevention system. Now, the difference between the next generation IPS and legacy intrusion prevention system is going to be all about offered functionality and the amount of information that a system can take into account when doing the inspection. If you think about the legacy IPS systems, like for example, IDS on the ASA, or maybe Cisco's 4200 series appliances, like 4240, which was part of the version 4 CCA security blueprint. Those devices, they primarily focused on individual threats, where the main detection mechanism used to deal with threats was simply signatures. And of course, those signatures, we all know that they must be kept up to date, they must be downloaded. Pretty much other than that, the only functionality offered was to perform inspection at the application level for some protocols. Well, there was also that anomaly detection, but this was more of like an enhancement that was Cisco proprietary. Other solutions, other legacy IPS solutions, they didn't offer even that. With next generation IPS, what is going to change is that we will be not only looking at individual threats, but we will be also capable of performing application level, extensive application level detection. We will be able to detect applications running in the network. We will be still able to do the inspection at the application level, which is going to be much more sophisticated than what you could do, for example, with 4200 series devices. We will be able to take the identity information into account. It is going to be possible to look at specific vulnerabilities or just bind vulnerabilities to the end systems and use this information to adjust our policies. The device will be able to come up with a context for the session. It is going to be capable of correlating this information, correlating those individual events, tying them together. We will be able to integrate with other security systems, like for example, Identity Services Engine. This is all what makes the difference between legacy and next generation IPS appliances. Okay, for the Firewall threat defense specifically, like if you want to run pure next generation IPS, so without using any of the firewall features, you will be able to deploy NGIPS in one of two modes. You can go for a passive solution, or you can go for inline deployment. Of course, with passive solution, as I explained in one of the previous sessions in another module of this series, this is when we will copy communication from the network using span or maybe remote span, and we will take the traffic from the switch, we will send it to the interface of FTD for inspection. We can also go for encapsulated span, or the other approach is going to be to cable the appliance, like if this was a real inline deployment, but we will also enable the tap mode, where the difference is going to be that the traffic is going to be technically flowing through the FTD. The device is going to be inline with the data plane, but we will still not affect those packets. We will perform detection kind of like off the forwarding engine. So we will not be able to affect the communication even when we detect an attack. And with inline, obviously, the goal is going to be to put FTD into the data plane, like with inline pair with tap. But this time we will be able to block the packets, maybe change, modify the content of the packet before it is sent through the appliance. You can still use NGIPS as part of the next generation firewall, in which case you would go for switched or just routed interfaces. But again, the passive and inline types of deployment, this is when you are looking for pure next generation IPS. So as I explained in one of the previous videos, some people might prefer such a mode because you will get more resources for IPS functions. Maybe you have other appliances that are running as firewalls. You just want to separate these two responsibilities. The next generation IPS on FTD is made of two main components. We will be dealing with normalization, and we will be dealing with intrusion rules. Normalization is just a process of inspecting packets, looking for certain anomalies, and even more importantly, performing some basic checks and modifications. The reason why we will need to perform normalization of the data packets is that the other sub-engine of the next generation IPS, the snort rule engine, is going to expect packets to be presented in a certain way. So NGIPS snort rules are written in a somewhat specific way, and they all expect a packet and its content to be presented in a standardized way. This is needed because obviously different flows, different protocols represent data in a different way. Like when you think about clear text SNTP versus clear text HTTP, in which case HTTP data is compressed, the representation of the data is not going to be the same. So this is going to be the main role of the normalization engine, to perform some basic checks on the packets, like verify the checksum, do the stream and fragment reassembly so that the packet looks the same as it will look on the end host. There are going to be some protocol specific checks like deobfuscation, like decompression, and a lot of other things that the device will be performing on the fly. And now specifically the component that is dealing with normalization is known as preprocessor. So preprocessor, this is what we will be using to perform normalization on FTD. The other function of normalization is also to detect some basic attacks and look for so-called evasion techniques, like when the attacker is modifying the flow so that it goes undetected through the NGIPS. Okay, the normalization settings, preprocessor options, they are all controlled by the network analysis policy, NAP, and this is something that we will be obviously able to tune. The second main sub-engine of NGIPS, as I said, is going to be the intrusion rules, specifically snort rules. Of course, this is what we will use to detect individual attacks. And as we will see in just a moment, there are going to be actually several different policies available by default, intrusion policies, where the difference between them is going to be in the amount of roles that will be active. So like with other types of IPS systems, IDS IPS systems, you will have that ability of enabling, disabling individual roles just to tune the system to your environment. And now those roles, in case of FTD, it can be one of two types. We can deal with shared object rules, which are all written by Talos. And those rules are generally written using the C programming language. They are compiled, and this way you will not be able to kind of like reverse engineer the content of those rules. They are deemed to be irretrievable, just based on the fact that they are proprietary. So it's Talos who writes those rules, sometimes with the aid of third parties, and they generally don't want you to see the content of those rules. And then you also have rules that are standard, which are reversible. This stuff you will be able to see when you added the rule, and this is also where you can add your own rules. When you add a custom rule, like you upload a text file or use the GUI to build a rule, this rule is gonna, of course, fall under the standard category because it is gonna be written in clear. Plus, since the rule is custom, the system is gonna tag the rule as a local entry. So whenever you see a local rule, it means that it was created by the user, not by Cisco. As I highlighted previously, there are several different default policies that are offered by FTD, and this is all about expediting the deployment. So in most cases, you will be using those policies because you don't really want to enable all those rules one by one. You want to rely on the Cisco's collective security intelligence best practices. you will select one of those default policies as a template, as a baseline for your custom policy, and you will perform tuning from there. Note that the concept of default policies applies to both intrusion and network analysis policies. Now, the difference between those policies, it is all about a number of enabled or just active roles and also enabled preprocessors and their settings. So Cisco gives us a couple options as what we can use for our baseline, depending on how secure environment you want to build. So we have the simplest policy, which is called no rules active. In this case, we don't use any of the signatures. So this is what you will use if you don't want to perform any type of intrusion detection prevention. We have balanced security and connectivity template. And this is, as you can imagine, this is what provides a trade-off between security and connectivity. And this is actually a recommended option for most of the deployments. And next is connectivity over security, in which case we favor network performance. There are going to be less rules enabled, and preprocessor settings are not really going to be very offensive in this case. The opposite is going to be to use the security over connectivity template, and there is also maximum detection, which in, I believe, certain versions of FTD, like versions of the code, it enables all available snort rules. Plus, it also uses the largest number of preprocessor settings, and those settings are the most offensive. So this last option, this is what is actually recommended for testing. You don't really want to use this option, this template, for a production network because you will easily overrun your FTD.